In this video, we are going to discuss inverse hyperbolic function. First, let us see the definition of inverse hyperbolic function. Okay, we recall back the definition of hyperbolic function. Okay, the first one, we have sin x equals to e to the power of x minus e to the power of negative x over 2. And then cos x equals to e to the power of x plus e to the power of negative x over 2. And tan x equals to e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x. From here, you can see that all formula under hyperbolic function is given in terms of e. Okay. Now, let me look for definition for inverse hyperbolic function. The first one, inverse sin x equals to ln x plus square root of x squared plus 1. Okay. And then inverse cos x equals to ln x plus square root of x squared minus 1. It's similar to formula for inverse sin, but in between in square root symbol is minus. Okay. And then inverse tan x equals to half ln x plus 1 over x minus 1. Okay. From here, you can see that definition of inverse hyperbolic function is given in terms of ln. Okay. And definition for hyperbolic function is given in terms of e. Okay. Okay, for sin x and cos x, okay, this formula is given in appendix. So you no need to memorize. Okay. But for tan x, this formula not provided in appendix. So this formula you can retrieve from tan x equals to sin x over cos x. Okay. So from sin x, we have e to the power of x minus e to the power of negative x over 2. And cos x equals to e to the power of x plus e to the power of negative x over 2. So when we divide sin x over cos x from here, so we have e to the power of x minus e to the power of negative x in numerator and e to the power of x plus e to the power of negative x in denominator. Yeah, this is formula for tan x. Okay. Okay, how about to memorize formula or definition for inverse hyperbolic function? Okay. If you are unable to memorize definition of inverse hyperbolic formula, you can retrieve from the integration of inverse hyperbolic function that is provided in the appendix in final exam papers. Okay. To memorize formula for inverse sin x, okay, you can refer from appendix formula number 17. Okay. But this formula is given for integration formula. Okay, you can see from here. Okay, and you replace a by 1. Okay, so from here, if we replace a by 1 here, so we have inverse sin x over 1, which is x, equals to ln x plus 1 squared, which is 1, plus x squared, square root here. Okay, x squared plus 1 equivalent to 1 plus x squared. Okay. Okay, for the second formula for definition for inverse hyperbolic function, which is inverse cos x, you can retrieve from formula number 18, okay, in appendix. So if we replace a by 1, so we have inverse cos x here equals to ln x plus here square root of x squared minus 1 here. Okay. And then to retrieve formula for inverse tan x, okay, if you are unable to memorize, okay, you get from this. We replace a by 1, so we have 1 over 2 here, ln x plus 1 here, over x minus 1 here, equals to 1 over 1, which is 1 here, inverse tan x over 1, which is x here. Okay, so you get this formula. Okay. And we also have other useful formula. Okay. E the power of ln x equals to x. Okay. We can simplify e the power of ln. Okay. But you need to be careful because coefficient of ln should be positive 1 here. So if we have e the power of positive 1 ln x, we can simplify, so we have x only. Okay. This formula, okay, is very helpful to solve inverse hyperbolic function. Okay. Now, let me see the example. Okay, this example is from previous semester papers. Okay, example 1, okay, is from page 41 in your handout. Okay, without using a calculator, find the exact value of 2 inverse tan 1 over 4 sin ln 3. Okay, so how to find this without using a calculator? Okay, without using a calculator here means that we need to use formula from definition of hyperbolic function and definition of inverse hyperbolic function. Okay. Okay. From this question, we can see that we have hyperbolic function, which is sin. So, from sin x, okay, equals to e the power of x minus e the power of negative x over 2, we can find the value of sin ln 3 without using calculator. But how? We can use this formula. Okay, we replace x now by ln 3. So we have e the power of, okay, x we replace by ln 3 minus e the power of negative, we replace x by ln 3 and then over 2. Okay. And after that, we need to write e the power of negative ln 3 to 1 over e the power of positive ln 3 using the properties of indices. Okay. From properties of indices, if we have negative exponent, we can move down, okay, but the power should be positive. Okay. Okay. Why we need to write e the power of negative ln 3 to 1 over e the power of positive ln 3 here? Because we want coefficient of ln positive. Okay. Why? Because from this formula, we have e the power of positive ln x equals to x. Okay. We can simplify e the power of ln, and then we have x here, but we need to be careful, coefficient of ln should be positive. That's why we need to change e the power of negative ln x using the properties of indices. So we have 1 over e the power of positive ln 3. So from here, we have e the power of ln x equals to x. So if we have e the power of ln 3, so the answer should be 3 minus 1 over e the power of ln 3 equals to 3 here. So we have 3 minus 1 over 3 over 2. Okay. And then from here, you can solve. Okay. So we have 4 over 3. Okay. From here, actually, you can use calculator to simplify 4 over 3. Because without using calculator, in this case, means that we need to use definition of inverse hyperbolic function and definition of hyperbolic function to find the value. Okay. Okay. E the power of ln 3 equals to 3. Okay. E the power of negative ln 3 equals to negative 3. Okay. The first one is correct. But the second one is wrong. Okay. Okay, e the power of negative ln 3, actually, we need to change using the properties of indices. So we have 1 over e the power of positive ln 3, which is equals to 1 over, here, we have e the power of positive ln 3, so equals to 3. So thus, e the power of negative ln 3 not equals to negative 3, but equals to 1 over 3. Okay. Okay, for e the power of negative ln 3 equals to negative 3 here, okay, this value is very common mistake. Okay, so you need to be careful. Okay, e the power of negative ln 3 not equals to negative 3 but equals to 1 over 3. Okay, use properties of indices first to make coefficient of ln equals to positive 1. Okay. Okay, then we can find 2 inverse tan 1 over 4 sinh ln 3. Okay. Equals to 2 inverse tan 1 over 4 times 4 over 3. What we do is we replace sinh ln 3 equals to 4 over 3. Where we get this? From here. Okay, sinh ln 3 equals to 4 over 3 here. Okay, this is the original question. And after that, we can simplify 4 from numerator and 4 from denominator here. And we get 2 inverse tan 1 over 3. Okay. Okay, now we continue from the previous slide. Okay, the previous slide we have 2 inverse tan 1 over 4 sinh ln 3 equals to 2 inverse tan 1 over 3. So from here, we can refer from definition of inverse hyperbolic tangent. Okay, we have inverse tan equals to inverse tan x equals to half ln x plus 1 over x minus 1. Okay, then we can write 2 times half ln 1 over 3 plus 1 over 1 over 3 minus 1. Okay, how we get this? Okay, how we get inverse tan 1 over 3 equals to half ln 1 over 3 plus 1 over 1 over 3 minus 1. Okay, we compare from this formula. Okay, but we need to replace x by 1 over 3 here. Okay, we have half ln x here, we replace by 1 over 3 and then plus 1 over x here, we replace by 1 over 3 and then minus 1 here. Okay, and after that, we can simplify 2 and 2 in denominator. So we have ln here, no more half and 2 here. And in modulus sign, we can simplify using calculator. Okay, because without using calculator here means we need to solve using the definition of inverse hyperbolic and hyperbolic function. So for any numbers, okay, we just press calculator to simplify. So now we have ln -2 in modulus. Then we can simplify modulus -2 by 2. So the final answer is ln 2. Okay? There is no need to convert ln 2 to decimal numbers. It is because the question are asked without using a calculator. So it is impossible to us to leave our answer in decimal. Okay, if we solve without using calculator. So we just leave the final answer as ln 2 only. Okay. Okay. Actually, we can solve this question using calculator. Okay. But in this case, okay, we need to solve without using calculator. Means that we solve using the definition of hyperbolic function and inverse hyperbolic function. But we still can use calculator to check the final answer. Okay, is it our final answer is correct or wrong? Okay. Okay. 2. First step we press 2 from calculator, and then the operation between 2 and inverse tanh here is multiplication operation. So we press multiply, and then there is no hyperbolic function in calculator. Okay. So to press inverse tanh, okay, first step we need to press shift for inverse, and then for tanh we need to press hyperbolic here, and then tangent, okay, here, and then open bracket 1/4, 1, then button AB over C, 4, and then between 1/4 and sinh is multiplication operation. So we press multiply here. Okay, and then sinh, to press sinh, there is no sinh button in your calculator, so you need to press hyperbolic sign. Okay, hyperbolic sign, and then for sinh, and then in bracket, okay, you open bracket, and then ln, and then 3, and then close bracket 2 times. Okay, got it? Okay, now let me show you how to check the final answer using Symbolab to solve 2 inverse tanh 1/4 sinh ln 3. Okay. Okay, first we need to type Symbolab in your Google search. Okay. And then just choose symbolab.com. Then we get this. Okay. And then under enter a problem, you need to type 2 inverse tanh. Okay, looks like tanh the power of -1. Okay. But it means inverse tanh actually. And then 1/4 sinh in bracket ln in bracket 3. Okay. And then we just press enter. Okay. And after that, we get the final answer ln 2. Arctanh means inverse tanh. Okay. And the decimal is 0.69 something. Okay. So this is the given question. Okay. Got it? Coming up next, the next example, find inverse sinh tanh ln 2 without using calculator. So, stay tuned. Bye. Assalamualaikum.